Is it an aircraft? Is it a satellite? Or is it a drone? No. More than an ordinary aerial drone, but not quite a satellite. Huge solar-powered airplanes. Some of them, they have huge fuselage, and others have large wings and tails, even wider than a jumbo jet wings. These kinds of airplanes will soon take a place in the skies. Everyone will feel this touch in the near future. My name is Sulaiman, and I will be talking about high altitude pseudo satellites in this video. We all know about drones, UAVs, and satellites, but pseudo satellites are quite a new concept for us. First, what are high altitude pseudo satellites? High altitude pseudo satellites, or HAPS, are planes and airships that can soar through the stratosphere, which is about 50 kilometers height. These planes can perform functions commonly in the domain of satellites. Pseudo satellites are most often transceivers devices that are used to create a local ground-based global positioning or GPS alternative. High altitude pseudo satellites fly above the conventional aircraft and offer continuous day and night coverage of area below. Target applications of pseudo satellites include many things. For example, intelligent transportation, search and rescue missions, disaster relief, environment monitoring, agriculture, and many other things. In addition, a primary goal to focus on is the internet connectivity. We know that there are about 4 billion people who are unconnected to internet, and pseudo satellites can really bring this issue to a solution and can be a game changer. The first aircraft of pseudo satellites kind to float in the stratosphere is called Zephyr. Zephyr harnesses the sun's ray running exclusively on solar power. High altitude satellites are able to fly for months at one time, combining the persistence of a satellite with the flexibility of a UAV. Zephyr planes have a very long wingspan, up to 33 meters, and minimum weight possible down to 75 kilograms. These specifications enable the pseudo satellites to carry and connect more payloads and scientific equipment. Another example of high altitude pseudo satellites is the Stratobus airship. Stratobus is a concept for an autonomous stratospheric platform midway between a satellite and a drone. The project was selected by the French Ministry of Industry and Digital Technology within the scope of the new industrial French program, and is being carried out with a group of partners including Airstar Aerospace. Stratobus is a 5-ton airship operating of an altitude about 20 kilometers above the airspace dedicated to air traffic and the jet stream, that can host payloads of 250 kilograms and provide 5 kilowatts of power. It will be 100 meter long and 33 meter maximum of diameter, and offer a lifespan in the stratosphere of 5 years. Although High-altitude pseudo satellites have been in development for more than a decade. It is known that technologies are coming together in communications, battery life, weight, and small existing Earth observing system. I mean the equipment that has made high pseudo satellites more visible are always developing and becoming better and better every day. The rush to develop these platforms by air transport and internet companies suggests their commercial application has great potential, while support by the European Space Agency indicates research benefits are also likely to come. To conclude my video, I would like to show you two simple comparisons between real satellite and pseudo satellite. Here is the pseudo satellites, here is satellites, real satellites, pros and cons. The pseudo satellites have no fuel, which means no emissions. Also, if the computer shut down, you can get the pseudo satellites back to Earth easily, and you can fix it. I mean, you can fix the error. While some of the cons are, they are short range time of usage. I mean, you cannot use it for a very long time. Also, limited area of spotting. They cannot spot very large area on the Earth. Let's move to satellites. Some of their pros are they can spot very large area, long range time of usage. It has time to work for many years until it breaks down. Some of the cons are they use fuel, which means emissions. They don't come back to Earth. Satellite signals can be adversely affected. By the way, if it breaks down, you can fix it, but it is very difficult and it takes too long time. Also, some of the cons are their solar arrays may fail. Here is my second comparison. This is the pseudo satellites and real satellites. The altitude of pseudo satellites is 21 kilometer. Satellites 35,000 kilometers. Duration, it can stay for from 90 to 120 days. For satellites, it continue working until it breaks down. For the cost, these pseudo satellites are very much cheaper than real satellites. They cost around $5 to $10 million. The satellites, it costs $50 to $400 million plus $500 million for space shuttle launching. Thank you for watching my video. I hope you enjoyed it, and see you next time. Goodbye.